So I had a question about the noise level. Wanted to know what it was. They thought it sounded loud on the video, so I'm going to measure the noise level here for the machine running at full speed. Got it read tension with the actuator. Went ahead and mounted my switch there Saturday. Production unit, I'm going to run that through the frame actually. Drill some holes in the frame and I'm going to run it through and feed it so it's all tucked inside and protected. Alright, let's go ahead and start things up here. Alright, here's 1/4 speed. And so you're going to be standing head height about 78. Maybe 79, got 85, 86 right down there on it. Got 80 at head height. And to 81 at head height. Let's see, we'll go up to 60 hertz. About 4 inches away from the belt. I'm not top pulling. At 88. Look at head high. 82, 83. Alright, we'll max it out. Down on the belt. Up the head high. 86. Got head high. My head high, not 5.5. That's a nice 6 feet tall. It's quieter up there. About 40. That's a little over half. A little over half belt speed. A good power. 6,900 cubic feet per minute. Power. Alright, so I've tweaked it up 1 hertz on the VFD, overdriving the motor by 16 hertz with a 6-inch wheel on it, given 7,085 surface feet per minute on the belt, so that's a good solid 7,000. It's got good power at that speed. It pulls well. It pulls even under the load of the guide. For those that don't have experience grinding that fast, there's some benefits and some differences that come into play. You don't push nearly as hard on the belt because the belt is doing more of the work by virtue of belt speed. And the guide, that the tool that actually does put a significant amount of pressure on the belt, I've had very good success with this so far. Ran a 36 grit belt on it Saturday and did some hard pulls on it, and it didn't overload the motor, overcurrent the motor or anything and cause it to shut down. It didn't lose any power even, which was good. I was impressed with it. The guide will mount on this device here. This is a thing that slides on to the tool arm, and then it actually, you can drop down here. So it's a removable item that can go on other tool arms. If you put a contact wheel on, you take this off of the platen and you put it onto the contact wheel by loosening that clamp and sliding it off the tool arm, and then sliding it on the new tool arm, and then the guide comes out here and over and mounts. I'll give some more demonstration of it. Here's the rest of the guide setup. I was using it Saturday night. So this arm here would slide into there, and then you can see where it come across the front of the platen, and then you have a vertical adjustment, and then the guide actually would go over the platen right here. One of the reasons that I've made this machine, or a machine with this kind of speed and power capability, is customers for my guide had begun to mention that they were overpowering their machines and that their machines couldn't keep up with the speed that they were now capable of grinding at by using the guide, because you can grind at very high speed and remain in control. I know a lot of guys that freehand, their comment is, I don't want to grind faster than 3,000 or 4,000 when they're freehanding, because, you know, they can make a mistake in a hurry, and I understand that. With this, for those that don't freehand and that are doing something a little bit different, this allows you to go extremely fast, and 7,000 is still well within the range of the Cubitron belts. What I use at those speeds is actually recommended. That's one of the recommended speeds is for steels, is up to 7,000 surface feet per minute to keep the belt sharp. Your belts cut good up to those speeds, they stay sharp. The grinding happens at such a fast speed that you don't put near as much heat into your blank, so a lot of the heat is taken away from the blank by the chips or the sparks. Carries a lot of the heat away at those speeds.